Today, we will explain the working principle and components inside the PEM electrolytic cell. Let's first take a look at them by disassembling them. The compression plate is made of aluminum alloy, used for fixing the entire electrolysis cell. The next one under the pressure plate is the insulating rubber ring, which is insulating and has sealing properties. Bipolar plates, BPP, are flat separator plates, either with metal mesh or screen lamination, or with etched flow field channels, thick metal separators, used to match the power supply voltage by stacking multiple electrolysis cell units in series, separate adjacent units, and connect them electronically. It needs to have low resistance and high mechanical and chemical stability, fluid distribution, and high thermal conductivity, as it also helps to promote heat transfer. Titanium is generally considered the most advanced material because it has excellent strength, low resistivity, high thermal conductivity, and low hydrogen permeability. However, titanium is prone to corrosion, especially on the anode side, where potentials may exceed 2V, leading to the accumulation of surface oxides, thereby increasing contact resistance and reducing thermal conductivity. To avoid this, a thin platinum coating can be applied to reduce surface resistance. This is a silicone ring, which has sealing property and fluid channeling property. The gas diffusion layer, or called the current collector GDL or PTL, as an electronic conductor between the MEA and BPP, ensures efficient mass transfer of liquids and gases between the electrodes and the BPP. At the anode, the liquid water transports from the passages of the BPP to the catalyst layer on the membrane through the current collector, where the water is decomposed into oxygen and protons. The oxygen generated here diffuses in the opposite direction through the current collector into the flow passages. At the cathode, liquid water and hydrogen are transported from the membrane to the passages of the BPP through the current collector. Electrons start from the catalyst layer on the anode side, pass through the current collector and BPP, and then reach the cathode side. In PEM electrolyzers, the anode potential is high enough to oxidize carbon materials, and other materials must be used. Titanium is often a choice for current collectors at the anode. The MEA consists of a proton-conducting membrane coated with porous electrocatalyst layers on both the anode and cathode sides. This is the core component of the electrolyzer, where electric current decomposes water into gaseous hydrogen and oxygen. At the anode, water is oxidized into oxygen and protons. The hydrated protons then migrate to the cathode. Electrons flow to the cathode through the external circuit. At the cathode, protons gain electrons and are reduced to form hydrogen gas. Iridium oxide is generally considered the most advanced catalyst in PEM water electrolysis. Ruthenium oxide has the highest OER activity, but it is not stable under electrolyzer conditions. Iridium oxide has slightly lower activity than ruthenium oxide, but has the advantage of higher corrosion resistance. Let us explain the working principle of the PEM electrolyzer. The water in our water tank comes in and is energized to form hydrogen gas. Its working principle is as follows. The water enters from the water inlet to the bipolar plates, then to the gas diffusion layer, and to the proton exchange membrane. By inputting current and voltage, oxygen is generated at the anode and hydrogen is generated at the cathode. The oxygen generated at the anode is output through the anode pipe, and the hydrogen generated at the cathode is output through the cathode pipe. A cathode output pipe and an anode output pipe are formed, and then go up to the water-gas separator to form gas.
This is PEM proton exchange membrane. This is GDL gas diffusion layers, ensures efficient transfer of liquids and gases. Bipolar plates match supply voltage, separation panels with layers of metal mesh or screen, or a thick metal plate with etched flow channels. Rubber layer insulating rubber layer, which acts as a seal. Compression plate serves as a fixation for the entire electrolyzer. Water are brought to the bipolar plates and flow into the channels of the plate. At contact with proton exchange membrane of the electrodes, the water is split into protons H+ and O2. The proton O2 splits off two electrons E, which combine with another to form oxygen. The electrons travel through the circuit to the cathode. H+ passes through the proton membrane to the cathode. Protons H+ combine with electrons at the cathode to form dihydrogen. Oxygen flows from the anode. Hydrogen flows from the cathode.